Okay, welcome. This will be the first part in a series of 4 parts for 4 Wells Gardner K7500 medium resolution arcade monitor chassis repairs. And all of these were sent to me as non-working. I don't know any other details other than that. So we'll start with one and we'll do 4 separate videos on 4 separate ones here, and we'll see what's wrong with each one. We'll see if we can't get them all working. So I'm going to get the camera set up on the overhead view, and we'll start with number 1 and put these aside, and we'll go through all testing all of the normal stuff you need to test, and we're assuming it doesn't power on, and we'll see what we can find. So stand by one moment. Well, first things first, let's get everything, all the ancillary stuff unhooked and out of the way, and we'll start doing some testing. So again, we'll disconnect the neck, the G2 wire, the whoa, what's going, I'll set this aside. What is up with, look how long that is. That should be about this long. So someone's been doing some stuff here. Interesting. Oh, sorry. Disconnect our remote board, and we'll get to those in a minute. But first, let's look this over. I don't see any missing components except for the transistor for the width, which I do have an extra one here. Basically, on a dedicated K7500 tube, there is a transistor here mounted to the frame of the tube, and you have to take this connector and plug it into here. If you turn it upside down, it doesn't work. It has to work this way. Basically, this is the transistor that's normally, you can see here that there's a spot here for another transistor, and there's not one there, and these wires run to here. So on a normal K7400 U2000, on a standard arrest chassis, any chassis basically, even the U5000, this is the only one I'm aware of that has the transistor mounted separately from the chassis. But you can see these wires go straight to where the transistor would be. If you look at a 7400, you can see that it's actually there. And this, I'd be able to read it to you if it didn't have a bunch of glue all over it. Yeah, you can see that on a normal one it's right there. But on the 7500 it's not, it's remote. So you have to have this transistor, because this will work without it. But if you try and adjust your width, it will do nothing. Width control does not work at all unless you have this plugged in. If you take this connector and plug it in, you know, with, I guess, I don't know how to describe it, I guess with the black wire to your right, you want to plug it in like this. If you plug it in upside down, it doesn't work. So if you plug it in like this, this will give you back your width control. So if you have a 7500 with no width control, make sure you have your transistor plugged in, which I'll show that later. So just wanted to get that out of the way. Otherwise, there's not too much difference between this one and the 7400. But I guess we'll go ahead and start testing the power circuit. Let's get rid of this. Again, you push down with your thumb here and lift up with your fingers, and then try and move your other finger to get it to kind of come off. Well, that was a lot easier than it should have been. But yeah, because sometimes if you don't do it properly, you can actually slash your fingertips open from the solder pins on the back from the components. So that's how I take this off of here. Linearity coil is secure, that's good. Okay. Well, yeah, everything seems intact. Let's look at the back side here. I don't... It says some work done, but they cleaned it up pretty well. It seems okay. Nothing burned or scorched, or I don't see any really bad. So I think someone's reflowed the flyback because it looks like they've used the wrong kind of solder here. It's not shiny, it's dull. So we may end up doing some reflowing, but it's got all new caps. It looks like someone's gone through and changed the caps out. You can see they put stripes on all of them, so it's got new caps. I mentioned before in the 7400 video previous to this one, they've changed out these 2 big bipolar caps. So let's go ahead and start testing. We'll test our Q101 voltage regulator. All right, again, it's these three right here. 1, 2, 3, this triangle. Base, one side, 0.5 is good, and 1.0 is good. So voltage regulator is okay. Let's do our switching mode power supply chip, negative on the left side. These two pins here, good. These two pins, good. That's what you should read, points, or like a diode and like a diode. This should be 1.7 something or other. 1.8 is fine. This should be 1.0, good. So our switch mode power supply chip is good. We'll test our, like I say before, I don't go through and test all the components, because if the switch mode power supply chip is good, it's very, very, very highly likely that the rest of this stuff here is good. Same goes for the voltage regulator. But again, if there's anything shorted in this area, simply testing this 10K ohm resistor will tell you that. So if we go to that was R104, yeah, if we test this one, 10K, 9.61. So I'm fairly confident that our power supply section is good. So I guess we'll do our C121, which is this guy here, which I mentioned before in the K7400 video. If C121 is a metal film capacitor, if this is bad, it'll blow the HOT. So we'll test that. It'll also keep it from coming on. So you just checking to make sure it's not shorted. So we put it on ohms and test it. It is not shorted, 1.1 mega ohm. So that is good. We'll test our 3 polycaps here. Was it C724, C720, where is that? Well, I always forget these. I don't have them memorized. Let's grab this one. C723, C724, and C718. So that corresponds to these two pins, not shorted, these two pins, not shorted, and it's these two for the smaller one, not shorted. Okay, next I guess we'll do the HOT, which again is, looks like someone's reflowed that already. That's kind of not a good sign, but we'll see. Hopefully it's good. Again, it's these three here. So we'll test the middle and go to one leg. Oh, sorry. I did that same thing the last time. That's good, 0.5, and that should be the same thing. Yeah. So HOT is fine. That's good. So far, so good. It's probably going to end up being like that K7400 where nothing was wrong. This was given to me as not working, but the 7400 was also not working, but it ended up being just fine. Let's test our diode here. Again, this chip here is basically a diode. The left side is the stripe and the right side is the non-stripe. So we'll go negative on the left, positive on the right. That diode is good. So that's another one you want to test. Let's see. On the U5000, you'll see here that there's an R760. Not populated on this one, but on the U5000, you've got R760 and R765. There's these two resistors here. If these resistors are in circuit, I'm sorry, they're not in circuit on the 7500 and the 7400. I don't think the U2000. I think it's U5000. But if you have a U5000, there's the R760 and R765. If either one of these are open, it'll blow your HOT. So if you have a U5000 that's blowing HOTs, you want to check to make sure neither one of these resistors are open, because that'll do it. So a little bit of side information tidbit on that. Oh, wrong way. Okay, well, I think that's everything except Q703 here. This guy here will keep it from coming on as well. So we'll test Q703. And again, that's these pins here. That's good. This should be, I think, 1 point something or 0.9. Yeah, close enough. do it the other way here. Here you go. And alright, so that's good. That's basically the last component that I'm aware of that would keep it from powering on if it's all good. So it looks like we are heading towards the same scenario with the K7400 of being just fine. We'll test our diode here for our vertical IC. The vertical IC is this guy right here, this guy there, and there's a diode down in here that you can check. If that diode is shorted, it's going to mean you're going to have vertical collapse at a minimum. So we can test that diode. And it is good. Something else we can check, not related to powering up, but there's two resistors here. This resistor here and this resistor here, if either one of those are open, or not necessarily open, but if they're open or way out of tolerance, you'll also have vertical collapse. So we can test those. It should be around 2 ohms a piece, so we'll test this one. Let me zoom out a bit. This one here, if I get a good connection on it, there we go. Well, come on. There we go, yep, 2.1, so that's good, and this one in here should read the same. That one's okay. I think it actually probably should be closer to 1. So yeah, if either one of these are open or way out of tolerance, you'll have vertical collapse as well. So that's something to also keep in the back of your mind. So it looks like, I don't know what to say. We're heading down that same path. So I don't see anything wrong. Nothing that, unless the flyback is bad, I don't see anything that would keep this from powering on, just like the 7400 previously. Zoom out a bit. Okay. Well, I guess we'll hook it up and see what happens. But we'll inspect the neck board too. Someone has done a little reflow on here. It looks like they've reflowed the connector for the remote board, which is good, and the neck board, that's good. They've reflowed the first 3 pins on the video header, but not the rest of them for some reason. They've reflowed the power connector. That's a good thing to do. And it looks very, very, very clean for the work that's been done to it. So this side's definitely not clean. I don't really care about or worry about the dust or the dirt. Normally dust and dirt will hold in heat, but with this level of dirt and dust, it's not really too bad. Not worth really worrying too much about. Well, okay, we'll set it aside. Let's check our remote board, make sure there's no busted pots. No, they all look okay. How about our neck board? Yes, you see these are already spread out. Someone spread those out already. That's good. These are all at an angle, which isn't really that big of a deal, but they should be straight up and down. And they've recapped all of this stuff, so it looks fairly decent. Let's turn it around. Oh, geez. Holy cow. Yeah, this is nightmare. Look at that. Yikes. Oh, my Lord. Oh, wow. And all this solder is dull. Dull, dull, dull. It's not shiny at all. So, you know, just for the sake of troubleshooting, let's go ahead and just hook it up and see what it's doing. Oh, there's some missing components here. There's missing components here. Look at that. There's a missing resistor and a missing jumper. Or no, it's a missing capacitor. Someone's taken out... Where's my other... Well, I got parts, fortunately, but someone's taken parts out of this thing. Now I'm really interested to see what's wrong with it. Very interesting. Okay, well, there's no real reason to even power it up and try it until we replace these components. But I am curious to see what it does with these missing. I'll tell you what, just for curiosity's sake, let's go ahead and power it up and see what it's doing with these removed, because I don't know why someone would remove those. I'm not sure really what it would be removed for. It looks like somebody, they desoldered one side, you can see through the board there, and then this side they just clipped off the pin, clipped off the other side of the lead. Well, fortunately I do have a spare board here. And you can see I've robbed quite a bit off of it over the years. Yeah, there's 3 transistors here. And if any of these go bad, you can lose a color or have a shorted color. You can have shorted colors if any of either of these resistors are bad. Shorted colors if you're, I'm sorry, yeah, full color of just one color if your main transistors are shorted. So if you've got, let's say the screen's all red, completely red, you can have this transistor could be shorted. You could have either one of these resistors could be open. You could have this transistor itself shorted, the main transistor. You could have an open resistor for the red. You can have a bad diode here. You can have one of these resistors over here be bad. You can have a bad chip here, which I mentioned before. That's where I stole that last one I replaced. This was bad, so I've had a bad chip before. The screen was all blue, couldn't adjust it out. You could have a broken bias pot. There really could be any number of things. There's a lot of things that could go bad on a neck board that give you missing color or shorted colors. So what the hell? Oh yeah, look at that. This is butchered. That's why I use it for parts. I even stole the neck socket for a different chassis altogether. But fortunately I can steal these 2 parts up here that are missing on the other one. So just out of curiosity, what we're going to do, oh, sorry, we're going to hook this up and we're going to see what it's doing. So one moment. Alright, all hooked up, back together, ready to go. Got everything hooked up, anode, neck, yoke, ground, video, and power. So we count to 6, everything is good to go. Got the test pattern generator here to mimic 25 kilohertz, medium resolution. It's turned on and it's set to medium res. And we're ready to fire it up. Hopefully it turns on. I got the width control transistor installed. Remote board ready to go. So fingers crossed it turns on. I don't see anything or any reason why it wouldn't unless it's a bad flyback. Now that I say that, look at the giant, it's busted right there. There's a giant chunk out of it. I'm not even sure if I should turn it on, but why not? There's no reason not to. Alright, well, here we go. Let's fire it up. Hey, well, 2 for 2 that turn on that I was told doesn't. And we have an image. And it's not very wide. Do I have width control? I do have width control. Yeah, so now if I was to remove this transistor, if I can do it with one hand here, yep. You see the image shrunk down, and if I turn my width pot again, nothing happens. So you have to have that transistor installed to have width control. Keep that in mind. I don't think I have green though. It's awful. Let's scroll to. Oh, I definitely don't have green. Look at that. Green's gone. No green. Not unexpected with how butchered this is and those missing components. So, well, it works. It's nice and crisp. I'm scared to even go near that flyback with the giant chunk missing out of it, but it's got a very clear and crisp image. It's just missing green. Interesting. So maybe this is what was wrong with this one. Who knows? So I don't have a flyback to replace this one, but obviously it is working. It's not arcing and sparking, and it's got a good clear crystal image. I don't know if you can, yes, that's very sharp and crisp. So it's really a nice image. I just have no green. So let's get to work on this neck board, see if we can get this figured out. Well, the first thing we're going to do on this, I think, is to get rid of all of the crappy solder on here and redo all of this. I'm going to just completely redo all of this because it just needs to be cleaned up and done properly. So let's do that first. I'm going to turn my desoldering gun on and my fan. And I'll try and talk a bit louder. Should be okay. So we'll let that heat up, and in the meantime, yeah, this is in dire straits. What we can do is, since we're missing green, we can go ahead and just test the transistor. Like any other transistor, you want to have diode checker settings set. And you want to go to the center. You know, there always is a triangle here. The center here, and then we'll touch one leg. Like the rest, it should be like a diode. There you go. The other side. I'm not sure if that's supposed to be open or if that's supposed to read 1.0 or something. Let's see what the next one reads. Okay, so obviously they're all, we had red and blue, so we know that that's correct. So all of our transistors appear to be good. It doesn't necessarily mean much. It could just simply be these missing components. Okay, so the transistor appears to be good. We can check our, we know green's probably the middle one, red, green, blue, red, green, blue, red, green, blue, however you want to do it. So we'll test this 2.7 K ohm resistor. That should read 2.7 K. Let's see, and it goes to, yeah, it goes from here to here. Goes from here to here. 2.7 K. 2.7 K and 2.7 K. So all of our resistors are good, the main ones. Let's test the individual resistors. These ones down in here, you know, these two. I've already stolen one from this one. So we can test them this way. Well, it's going to be easier to do probably this way. So we'll test the first one here, and you can see how we do this. 0.9, 0.9, 0.7. Now we'll do this set here, 146, 149, and 145. So those resistors are all good. So let's test this transistor right here, this one. We'll go on the back side and we'll do center negative and we'll do diode. Okay, so that one's opposite. So center positive. There you go, that's good, and that's good. So that transistor is good. That one's good. That one's good. Okay, so our 3 transistors here are good as well. Let's test our, there's diodes down in here, these Zener diodes, 1, 2, and 3. So we'll test our Zener diode. Good, good, and good. Okay. Next, I guess what we'll test are these 3 transistors here. These can go bad, that cause either all color or no color. So we'll test them here. We'll do all right. Good. Good. And good. All right. Well, that's usually everything that can cause no color or all of one color. The green bias pot looks intact. We can wipe it back and forth a bunch of times. It's usually a good idea to take, they've been sitting in one position for so long. We can adjust them back and forth and back and forth, and let's get my jeweler's flathead here. Make it just a bit easier. We'll do back and forth and then set it to the middle. Back and forth, set to the middle. Same thing with the rest of these. Well, okay, let's replace those missing components. All right. But first, let's have fun with this. There's one. There's two. I'm pretty sure that's a green, so we'll set that one aside just for separation. Wow, this is going to be quite the deal here. I'm gonna have to take these off of here first. Well, there goes that wire. There goes that wire. There goes that wire. And there goes that wire. All right. Well, and there goes that burned up trace. Or not. Let's see why. Why ask why? Try Bud Dry. Oh, there. Jeez. Alright, so we've got all this junk here. Alright. And I've got a bag full of component leads here somewhere. Those are diodes. Well, thought I did. Say what? Yeah. Well, I have to use those. As you can see, I got a giant bag of miscellaneous junk, so let's use some resistor legs. I had a whole bag full of these leads for this exact purpose, but I don't know what happened to it. And that's okay, I'll grab an axial cap here and we'll use that. Probably have to end up using two of them. Which I don't even see another one in this bag of junk, so we'll grab this one. Oh, I've already done, look at that, I've already used this one for a leg. Huh. Well, might as well use the other one. Okay, and you want to use thicker leads, thicker legs, not just like on the smaller caps, like this one there. You want something a bit thicker than the smaller legs, so we'll go with that. Okay, might as well remove our other missing components here, which were this capacitor. Right out. And this resistor. Now that ground plane takes a while to heat up. So that side's out. Oh, now I know why that's why. That's exactly why. They were able to desolder the side without the ground plane, and the ground plane was so bad, it soaked up so much heat, they couldn't get it desoldered, so they cut it off. That's exactly what happened. Well, let me just leave this on here for a moment, work it around. And there it is. Let's grab our tweezers here and take one side out and the other. Just as easy as pie. Let's try and straighten our legs here so it goes in a bit easier. And then we'll have to get rid of this side. Oop. I heated up much quicker than the other one. Alright, that's good, and there we go. Okay. Let's see if we can grab. That fell out, and that other one's gone. So yeah, sweetness. Okay. Let's get our resistor in here. On camera preferably. There we go. Alright, that's in. And our capacitor. There we go. Okay. Come on. Any day now. I don't know if that's going to work or not. Get back in there, okay. Well, it doesn't like that for some reason. Nope. That's about as close as you're going to get. What's supposed to be there? Nothing? There's a missing transistor too. See this transistor here? They got a missing transistor with a jumper there. And it used to be there because someone's desoldered the center of it. Who in the hell hacked this up like that? There's also a missing, the capacitor's missing too. It's missing the capacitor in it. Well, oh geez, someone really butchered this thing. Why they did that, I can't tell you. But we're gonna fix it. Alright, can I zoom in now? Oh, almost. It's gonna have to be like that. Sorry guys, alright. Okay. Well, there you go. Still doesn't like to zoom in, I guess, but nice shiny joints. So you can see those compared to, say, the rest of these, how dull those are. You know, but someone used the wrong kind of solder. What's all this bullshit here? Huh. Odd. Well, alright. That is just, I don't know what's going on with this thing. Let's get rid of this jumper. Jumper out. In the garbage it goes. Let's take our transistor out here. You know, one of the reasons could be the revision of the board, but I don't think so, because there's no reason why those components would be missing, and the fact that the center had a hole that didn't have solder in it. If it was factory, there wouldn't be missing solder in the hole. So I'm going to remove. Oh, I missed the other leg of the capacitor here. I'm going to remove this capacitor, and it goes with the negative stripe goes inboard, and we'll remove our transistor here. Okay, now let's get this one in. Straighten our legs here. And you want to make sure to get it in the right way. See the curvature this way? So you want to get it in the right way there. Alright. There we go. And we want to get our capacitor in here in the right way. I gotta get rid of the solder on this first here. Yeah, someone definitely cut that out, because the leg of the capacitor that's supposed to go in through here, there's already, the old leg is still in there. So I'm not sure if I can get that out of there fairly easily. Can I push it through? Got it. Got it. Okay. So So now we can put this back in here. Negative goes this way. Get in there. Not wanting to go in. Straighten it out. Success. Alright. So let's see if I can zoom in on it now. Ah, god dang it. Why does it not like zooming in all of a sudden? I can't tell you. Well, I apologize about that. So we'll grab this and that, that, and that. Alrighty, that should be our capacitor. That should be everything that's missing. So now let's clean up. Now that we've tested everything else, let's clean this up again on the other side and see what we can figure out. Yeah, this is pretty bad. You know what I'm going to do? Well, I guess there's not really any reason to do that if I don't have to. I was going to take the traces off completely, but we'll leave them on there. And we'll just bypass them. So I'm going to get rid of a lot of this old shitty solder. By the way, when you hear someone use the word reflow, this is what reflow is. Reflow is remove the old solder and put new solder on. It doesn't mean reflowing what's already there. Just a bit of side note of information for you. I'd like to get rid of this crap too, but there's a lot of it. The rest of this isn't too bad. I think that'll be okay. Yeah, I think that'll be okay. So let's clean our gun here. Clean the tip off, put it back. Okay. So let's add fresh solder here to what I just removed. Making sure you don't remove the component by mistake. There we go. Yeah, those pads have seen better days. Alright, so that's good. Let's do this here. Okay, let's make sure we didn't create any bridges by doing that. I did. That, my friends, is why you double check. All right. So I guess let's let's do the nasty now here with this. All right. Let's see if I can. Start with the inside one. Really? Okay, there we go. Now, does this sit flat now? There we go. See, now it sits flat. That's what I want. And we'll have to see if we can make our jumper here. So we want to connect this pad, follows this trace to here, and then goes here to this one. So there's a couple of ways you can do this. You can scrape away the solder mask on here and just create a solder bridge around this area, or you can just reinforce it. So what we're going to do is we're going to chop this off, and we are going to create a bridge here. There we go. And we're just going to use this to mimic the movement of the trace straight to the pin. Just like that. That's what it should look like. Now we'll add a bunch of solder to this. Hold it there, and then we can cut this end off if we're lucky. Okay, there's the piece, and we just repeat this procedure until we get all of the traces redone. So now let's go to, where did I put that bastard? There it is. So now you want to do the same thing here. Which is going to end up right like that. Roughly there. Okay, this is a grueling process sometimes, but this is about the only way to really do it. So that popped up, that's not a big deal. Just want to hold it in place while I finish this over here. That's good. Now we can take our tweezers here and hold this down a bit. And there you go, there's one down. And you can see that this is still flat on here, the way it should be, not kinked over, and it's actually really solid now. It's much more solid than it used to be. That's why you want it flat against the board. So instead of making a jumper here on this one, we could, but what I'm going to do here is the alternate method, since I have that at my disposal here. We're simply going to scrape away our solder mask. And we're going to fold this over if I'm able to. I doubt that I will. Folds the opposite direction. There you go, that should be okay. I don't know if you can see that, but it's folded over a bit. And what we'll do with all this solder mask scraped off is we'll just create a bridge. Just like this. Hold that on there so it heats up. There you go. That's all you have to do. And again, that is strong, right? Unless you break it, that is very strong. So, yep. Now it's time to do the third one, and then we'll repeat the process for the rest of them. So I'm going to bend this over a bit again, this other leg here, and we'll scrape off our solder mask. Brush here. Okay, finished bending that over. And let's solder up that one. You're gonna leave it on here for about 6 seconds or so to heat up the tray so the solder sticks to the trays. And may have to use some flux here. Yeah, this is not working the way I was hoping. Smooth that over a bit. Where's my flux? Go. Well, we have to go back to our other method here because that's not working too well. There we go. That's a good joint. There you go. Perfect. So it may look a little unorthodox, but it's better than it was. And solid. It wiggles a bit, of course, but yeah. So that's how I do it. I scrape the solder mask off and do it this way. If it's close enough to the pad that's missing that I can bend the leg over and do that, I do that because it creates a more solid joint. This one over here was no saving that one. So yep, let's do the rest of them. This was the green one that was suspect, so before I go to the full 9, I'm going to install it in the middle here and just make sure we have green. If we do, then I'll fix it up proper, because this looks to be intact. All the solder pads, all the traces are intact on this one, so I'm going to actually try and I can fix this one afterward. And okay, flat against the board. Well, it was. Of course, none of the traces are cooperating here. There we go. Okay. So let's solder this in just the way it is. And we'll come back and do, well, these pads are roasted. They're so roasted that the solder doesn't even stick to it. Look at that. So this will be good enough for testing, but it would not be good enough for a permanent solution. But it looks like I can do the same thing. I can scrape the solder mask away on this leg and this leg, but this one here is going to have the jumpers again. Alright, that's completely ridiculously terrible, but it should work temporarily for what we need. And even that is still somewhat solid, yeah. Yeah, you want to have these all the way flat. That'll keep them from bending, and that'll keep these traces from breaking off the board. But it looks like this should be good enough. Sometimes you can take a fiberglass pen and scrape all these off and restore the pad, but with all the heat, it's just better to put the jumpers. You don't got to really worry about ever getting oxidized again. So that should be good enough. Let's test our continuity. So we want here to here through the trace. That's good. We want here to here. And we want here to here. Good. So that should be good enough for testing. When it comes to our last one, let's get this in here. Okay. See that? That's how you want it. Perfect. And again, these have to be spread out. So now we're cooking with gas. Let's get this last one finished here, and then we'll try it out. Oh, not like this. Not like this. Believe it or not, you son of a bitch. How can he be the one if he's dead? Okay. Let's do that method here again. You can also use a fiberglass pen to do this, what I'm doing here. But it's just easier for me at the moment to do it this way because I don't have my fiberglass pen on hand. right. Beautiful. That should work well and be nice and secure. And we'll do this one on in frame, hopefully. Oh, come on. Hold it down. There we go. Got it. So I think that's going to be good. Now it's time to do this. Bend that there. Bend that there. And chop it off it. Alright. So if we hold that and go here. One more. And that there. And there. Chop it off of it. Well, there we go. That's not pretty, but it's a lot better than it was. And we'll test this, make sure it works. If we have green and it's working, I'll do the same procedure with these as this one. And that should make this last a good long while. You can see they're all nice and flat, perfect. Resistor split out. They are very secure. And we got our missing parts back in. So, cross our fingers. Let's see what happens. Well, here we go. Do we have green or do we not have green? Let's find out. We're all hooked up, ready to go. Test pattern generator's on and in medium resolution. So here we go. Haven't tried it yet. Share with me in the knowledge if this has green now or not. Why is my contrast so bloody high now? It does not look like I have green. Well, I've got something. Got something there. Wiggle this around a bit. Nope. Is it a fault of my test pattern generator? Nope. Nope. Well, it may be a chassis issue, but now at least I have the outline of where green should be. Maybe that's because the brightness is too high. Probably. Yeah, brightness is too high. There you go. Interesting. Well, let's, I guess we can swap the transistor. I can put a different transistor in here. Maybe even though it's reading good, it could simply be bad. So let's try that. And then because this video is so long already, I'll do that off camera and we'll come back and see if it worked, and I'll let you know. Obviously if it does, you'll see green. If not, I'll continue on. But then if that doesn't work, I'll swap out the neck board with another one. I have a bunch of these. And if that doesn't work, I'll do some troubleshooting here on the main chassis. And because this video is so long, I'll go ahead and try and get this fixed, and I'll report back what the issue was in a moment. So hang on. Alright, well I fixed it. And you'll never guess what it was. It was the transistor. Even though it read exactly perfect in circuit, it reads completely perfect out of circuit. Even though all of that, it's still bad. Because I have an extra little tub here of extra parts, and you can see I've got extra transistors. There's one in here. There's another one sitting right here without the heatsink. I even have an extra U501 chip. I think it's 501. Yeah. So I have a bunch of extra parts, but I just decided on a whim. I looked through and used comparative readings against another neck board that worked, and I found nothing wrong. No open pots, no open resistors, no open diodes, no open anything. I even going through pin by pin on U501, I think it's U501. I forget. Anyway, the main processor chip there on the neck board. Pin by pin, everything, every single thing checked out. So I'm like, you know what? Let me just throw another transistor in there just for the hell of it. And sure enough, I put another. You can see it's kind of a different color. The heat sink, because hasn't been as hot, hasn't got as much use out of its life as this one did. I put a new one in, and check it out. Turn that on. Turn this on. Oh, I'm gonna have to press the button here to change to the color. But yeah, now I have a white balance here. There's my green. So there you have it. The whole time it was just a bad transistor. So now let's get the camera set back up again, and we'll do the correcting on the pads, and we'll call this one fixed. So the final work is done. I got the traces here repaired for the green one. It's not the world's most beautiful repair, but you can see that we've got the one with the lifted traces, you know, replaced here with new leads. This is bent over and soldered to the trace by scraping away the solder mask. This is here as well. We got this trace repaired. This is bent over, touching the mask, and that's scraped away. Another mask repair, and then of course this again, and same thing. So these are now nice and flat the way they're supposed to be, and there you can see how much further down that replacement green one is. I like this much better, but they're all secure as long as you don't go smashing into them. You know, they should be good. We got our resistors spaced out. Yeah, and one last thing. All of these repairs I did are completely and totally unnecessary. I think somebody performed this mod. It's P719i is the revision of this neck board. There's P17-J, P17-H, P17-I, and I is the latest revision that I'm aware of, and it looks like that on the I revisions, this is a normal mod. To remove this resistor, this capacitor, and this transistor are all part of a mod on the latest revision. Now, it's not going to hurt this to leave it in there, but this is something that I did not have to do. And I noticed that because on the other neck board that I was using that was good to do my testing against, it was also an I, and it happened to have all this stuff removed. But what's even more curious is that if this was a factory mod that removed this, why was the middle pad devoid of solder, and it looked like somebody had desoldered it? This looked like a bunch of handmade, and someone had done the mod afterwards. So that makes me think that maybe this was an early version of the I, and this stuff used to be in there, and someone took it out as part of the mod service kit. But I don't think, honestly, it's going to hurt to leave it in there, so I'm going to just leave it in there. But yeah, so the final repair is done. Let's hook this back up on the tube and see how it looks. Give it one final clean bill of health, and we'll call this extremely long video complete. Alright, all hooked back up, and let's turn this on, and we're still set to medium res, and let's see what happens now. There we have it, white balance, so we have all of our colors, RGB, we've got width control, we've got H position, we've got vertical hold. If I can turn it, won't let me turn it. No? There it goes. Vertical hold's good. Vertical position. Now the height's too big. Height, vertical position, good. Brightness, Contrast. Ooh. So there you have it. All the controls are good. We got RGB. And yeah, so a successful repair. Sorry it took so long, but it looks like almost, well, actually all the issues were all on the neck board. Just a real bear to really get these things tuned in just right. And I'm still kind of concerned about that flyback having a giant chunk out of it. I don't know what that's about, but I don't have any on hand to replace it with, and it seems to be working good, so I'm not going to worry about it because, like I say, I don't like to replace components just for the sake of replacing it, because who knows if the one I get will be good. So I'll just leave that for now. But yeah, everything on the main chassis is functional. It turned out to just all be an issue with the neck board. But now you can see it's good to go. So we'll call this repaired, and we'll move on to K7500 number 2 next. So stay tuned.